4,800 acres of the Everglades caught fire between Sunday afternoon and Monday morning. The news is reporting it as a wildfire. It is not a wildfire. It is the first visible piece of something underneath South Florida that has not yet entered the public conversation. And once you see it, you cannot unsee it. By the end of this video, you will understand exactly what is causing this, why 5 separate since records began benchmarks have already been broken in a single season, and what the next 30 to 60 days are about to confirm. Let's dive in. The Max Road Miramar Fire ignited on Sunday, May 10th, 2026, at a location near the intersection of North Chrome Avenue and Northwest 186th Street, along the Broward and Miami-Dade county line, approximately 1 mile from Max Fish Camp. At 2:05 in the afternoon Eastern Time, the National Weather Service office in Miami reported the fire at 80 acres with 0% containment. GOES East satellite imagery confirmed a developing smoke plume forming over western Broward. By 5 p.m. that same evening, the Florida Forest Service had revised the size to approximately 4,800 acres. By yesterday morning, the size was reported at least 5,000 acres, with 20% containment. You are watching a fire that grew from 80 acres to 4,800 acres in about 3 hours. That kind of growth in the Everglades in mid-May is the first sign that the story I'm about to tell you is not the story you are seeing in the news cycle. Firefighting crews from the Florida Forest Service, Miami-Dade Fire Rescue, and the Broward Sheriff Fire Rescue Division have established a defensive perimeter around the Holly Lake community in Pembroke Pines, near the intersection of U.S. Highway 27 and Pines Boulevard. Chrome Avenue is closed from U.S. 27 to the Tamiami Trail. Drivers have been warned of near blackout smoke conditions on U.S. 27 and Interstate 75 at Alligator Alley. Florida Forest Service helicopters are conducting continuous water drops. Health officials in Miramar and Weston have advised residents to keep windows closed, switch HVAC systems to recirculate, and asked anyone with respiratory conditions to remain indoors. No mandatory evacuations have been ordered. Residents along Max Road reported flames briefly cutting off the only roadway out of their neighborhood. The cause of ignition has not been disclosed by any agency. The fuels burning right now are dry sawgrass prairie, brush, and invasive Australian pine and melaleuca on Everglades National Park and adjacent state lands. And that's the second sign that something is wrong. Sawgrass prairie is not supposed to burn. Sawgrass prairie sits in standing water for much of the year. The fact that 4,800 acres of it can sustain an active wildfire on May 11th, 2026, tells you the surface and shallow subsurface water budget across South Florida has been gutted. And it gets worse, because this is not the only fire. Florida has 61 active wildfires burning across the state right now. More than 130 wildfires have been worked over the previous 72 hours. The year-to-date count for 2026 stands at approximately 2,000 fires, with more than 120,000 acres already burned. Of Florida's 67 counties, 49 are currently under active burn bans. Violations carry fines of up to $500. We are 41 days from the official start of summer, and Florida has already reached its annual non-extreme year acre total. Other large active fires across the state include the Railroad Fire at 4,796 acres, 80% contained. The Sargent Fire at 2,523 acres, 81% contained. The Cow Creek Fire at 2,364 acres, 60% contained. And the 172nd Avenue Fire in South Miami-Dade, near Florida City, at 210 acres and 30% contained. The 172nd Avenue Fire has forced the closure of Card Sound Road and reduced visibility on U.S. Highway 1 near mile marker 126. Florida's annual baseline is roughly 2,000 to 3,500 wildfires, burning 100,000 to 200,000 acres in a non-extreme year. By mid-May, the state has already reached the lower bound of that annual range. The operational fire calendar is running approximately 6 weeks ahead of seasonal norms. Florida's Keach-Byram Drought Index typically peaks in the months of May and June. In 2026, those peak values arrived in late March. What you are seeing in the Everglades right now is not a fire. It is the visible surface expression of something underneath the Everglades and underneath the entire Southeast. To understand what that is, you have to stop looking at the smoke and start looking at the water table. According to NOAA's National Centers for Environmental Information, the contiguous United States just experienced its driest January through March on record. The CONUS averaged precipitation total for the first quarter of 2026 was 4.79 inches. That is less than 70% of the long-term average. It is the lowest value on record for any January through March interval since national tracking began in 1895. The previous record was set in 1910. That is one record broken in a century-plus baseline. The second record is the CONUS-Palmer Drought Severity Index for March of 2026. The Palmer Index came in at negative 7.84. That is the most severe March reading in the same 131-year record. Two related records broken in the same season. The combined statistical weight is unusual. The third measurement that tells you this is not a normal drought is April 2026's severe to exceptional drought coverage. 43.8% of the contiguous United States was in D2 to D4 drought conditions in April. That is the largest extent for any month since August 2012, when the Corn Belt drought of that summer reached its peak. As of May 5th, 2026, the U.S. Drought Monitor Weekly Bulletin showed 60.92% of the lower 48 states in drought, roughly double the 10-year average drought extent for early May, which typically runs in the 20 to 30% range. We are at the beginning of the growing season, with twice as much drought across the contiguous United States as the climatological norm, while the equatorial Pacific is loading what could become the strongest El Niño in nearly a century and a half. These are not isolated data points. They are converging. The southeast region of the United States is now at 99.8% drought coverage. That is the third, since records began, benchmark broken this season. The regional drought coverage record for the southeast goes back to the year 2000, when the U.S. Drought Monitor began tracking regional statistics in their current form. The previous maximum was 86.2%, set in August 2007. The April 21st, 2026 map shifted the regional record by more than 13 percentage points. The fourth, since records began benchmark, is the Southeast Drought Severity and Coverage Index. The DSCI exceeded 350 for the first time on record. Approximately 60% of the Southeast is now in D3 to D4 drought conditions. When you look at the state-by-state breakdown, the regional regime change becomes clearer. North Carolina is 100% in drought. Virginia is 99.95%. South Carolina is 99.34%. Florida is 98.99%. Georgia is 98.13%. Tennessee is 93.65%. Alabama is 88.66%. 7 southeastern states are simultaneously above 88% drought coverage. The southeast region recorded its driest April in 40 years at roughly half of average precipitation. 6 Atlantic coastal states from Georgia through Delaware are in their top 10 driest Aprils. The fifth, since records began, benchmark is the most striking one. Georgia, North Carolina, and South Carolina Each set a record dry September through March in 131 years of state-level precipitation tracking. 3 Atlantic states, simultaneously, breaking a 131-year baseline for the wet season tail. Pamela Knox, the agricultural climatologist at the University of Georgia, has assessed this regional event in plain language. She said, quote, "Unfortunately, this looks like it's going to be another one of the big ones." End quote. She added, quote, "One of the things that makes the one we're in right now so unique is that it's drier much earlier in the year." End quote. North Carolina's D3 extreme drought classification expanded from 47 counties to 61 counties in a single week. That is flash drought tempo. This is not a slow developing event. This is a regional regime change that is intensifying on a week scale. Florida is currently at roughly 99% drought coverage. 13.81% of the state is in D2 severe drought. 53.52% is in D3 extreme drought. 24.99% is in D4 exceptional drought. About 85% of the state has been in D2 or worse since mid-February. NOAA's NIDIS describes the current Florida hydrological deficit as the third driest September through March period on record for the state. The I-10 corridor from Tallahassee to Jacksonville is running 20 to 30 inches below normal precipitation over long-term horizons. Soil moisture in western South Florida sits at the 5th to 10th percentile. In eastern South Florida, it sits at the 10th to 20th percentile. Lake Okeechobee's current elevation is approximately 19.89 feet, which is above the typical 12.5 to 15.5 foot managed regulation range. That sounds counterintuitive. The lake is high because the state has held water in storage to meet irrigation and ecosystem demand through the dry season tail. The water that does exist in South Florida is sitting in Lake Okeechobee and in regulated canals. The natural surface water across the Everglades prairie is gone. There is a popular intuition that Florida is too wet to burn. The historical record disagrees, and the historical record is unambiguous. In 1998, Florida burned. The fires that year produced roughly 499,000 acres burned across the state, in approximately 2,200 fires. About 120,000 Floridians were evacuated. Flagler County was the first countywide evacuation in Florida history. Suppression and damage costs ran between $620 million and $890 million. The fires were triggered by an ENSO transition out of the strong 1997 and 1998 El Niño into La Niña. In 2007, the Bugaboo Scrub Fire Complex in the Okefenokee Swamp on the Georgia and Florida border burned more than 564,000 acres. It is the largest single wildfire complex in Georgia or Florida recorded in history. In 2011, the Honey Prairie Fire in the Okefenokee burned 309,200 acres over almost a full year. La Niña winter. In 2017, the West Mims Fire in the Okefenokee burned 152,515 acres, with significant peat involvement. In 2022, the Bertha Swamp Road Fire in the Florida Panhandle burned 33,131 acres, fueled by 72 million tons of dead trees downed by Hurricane Michael in 2018. Florida burns when the water leaves. The water is leaving on a timeline no one prepared for, and underneath the surface, fuels in the Everglades is a substance that has not yet entered the public conversation, but which is the reason this story has to be reported now. The Southern Area Coordination Center, the federal body that issues fire weather outlooks for the southeastern United States, included the following observation in its May 2026 outlook. Quote, "Established large fires throughout South Georgia and North Florida are burning as deep as 3 to 5 feet down into the duff layer, and may be on the landscape for months." End quote. That is the operational signal that peat ignition has already begun across the broader Southeast fire complex. 3 to 5 feet down means the surface fire has consumed the litter, then the duff, then ignited the carbon-rich organic layer beneath. Once that happens, you are no longer fighting a wildfire. You are waiting for rain. The Everglades peat layer is up to 3.7 meters deep, roughly 12 feet, in the interior basins of the wetland. It is approximately 5,000 years old. It contains 30 to 45% carbon by mass. Globally, peatlands cover only about 3% of Earth's surface, but they store more than twice the carbon of all forests combined. The Everglades alone has lost roughly 300 million metric tons of carbon to drainage over the past 150 years. The physics of peat fires are different from the physics of surface fires. Peat fires are dominated by smoldering combustion, not flaming combustion. Smoldering temperatures run between 500 and 700 degrees Celsius. Propagation rates are 1 to 10 centimeters per hour. The fire moves slowly, but it moves continuously, and it moves underground. Duration is measured in weeks to months. In deep peats, a single peat fire can persist for more than a year. The natural fire break for peat fire is the water table. When the water table sits at or above the peat surface, the capillary saturated layer arrests downward propagation. When the water table drops below the peat surface, peat ignites top-down, then propagates downward and laterally. You cannot extinguish a deep peat fire with surface water. You can only re-wet the substrate or wait for sustained heavy rainfall to do it for you. The emissions are dominated by fine particulate matter, PM2.5, with toxic constituents that include hydrogen chloride, hydrogen cyanide, benzene, and polycyclic aromatic hydrocarbons. Carbon monoxide concentrations near the fire front can reach 200 parts per million. The historical reference class is severe. The 1997 Indonesian peat fires, which occurred during a strong El Niño year, released between 0.81 and 2.57 gigatons of carbon. That release is equivalent to 13 to 40% of total global fossil fuel emissions in that year. Approximately 15,600 child, fetal, and infant deaths were attributed to the resulting pollution. The 2010 Russian peat fires contributed to approximately 14,000 excess deaths in Moscow alone during July. The 2015 Indonesian peat fires, also during a strong El Niño, were linked to 91,600 premature deaths inside Indonesia and $28 billion in regional economic damage. If the Max Road Miramar Fire reaches the peat layer beneath the Everglades, the question stops being, how do we contain this? The question becomes, how long until the rain? Everything I have described so far, the fire, the 61 wildfires, the 131-year drought record, the regional regime change in the southeast, has a single upstream cause. The cause is sitting in the equatorial Pacific Ocean. The Niño 3.4 weekly anomaly, for the week centered April 15th, 2026, was plus 0.5 degrees Celsius. That is the warming edge threshold for El Niño classification. The NOAA Climate Prediction Center's April 9th, 2026 ENSO diagnostic discussion placed the probability of El Niño emergence in the May through July window at 61%. The probability of a strong El Niño, defined as Niño 3.4, reaching or exceeding plus 2.0 degrees Celsius, was placed at 1 in 4. As of this update, the operational forecast position has only escalated. Pacific subsurface heat content has been increasing for 5 consecutive months. The equatorial subsurface temperature index is above average across the entire basin. The 300-meter temperature anomaly reached plus 1.6 degrees Celsius in the first week of April 2026. James Hansen, the former director of NASA's Goddard Institute for Space Studies, characterized that subsurface signal in plain language. He said the 300-meter temperature alone is sufficient to, quote, assure, end quote, an El Niño in 2026 and 2027. Pacific subsurface heat at 100 to 250 meters depth across the central and eastern equatorial Pacific is documented as warmer than at the equivalent stage in either 1997 or 2015. Both of those years produced Super El Niños, events large enough to reorganize global atmospheric circulation, drought patterns, and food systems. The European Center for Medium-Range Weather Forecasts, which runs the SEAS-5 seasonal forecast system, released its May 2026 update last week. The result was extraordinary. 100% of the SEAS-5 ensemble members reached the Super El Niño threshold of greater than plus 1.5 degrees Celsius in Niño 3.4 by November 2026. The March 2026 release was at 55%. The April release was higher. The May release is at 100%. That is a forecast shift of nearly half the ensemble in 2 months. The multi-model median peak Niño 3.4 anomaly, forecast for late 2026, calculated by Zeke Housefather at Berkeley Earth, is plus 2.7 degrees Celsius. That is comparable to the 2015 and 2016 event, which itself was one of the 4 strongest El Niños in the modern instrumental record. The same ocean signal that ECMWF is now flagging at 100% of ensemble members is producing the Walker Circulation reorganization that has locked the continental atmosphere into the persistent ridging pattern. That ridging is what has dried the Everglades enough to burn. The fire I described in the first segment is not caused by a dry spring. It is caused by the Pacific Ocean. There is one more piece of the atmospheric signature you need to know about, because it is the strongest single piece of evidence that the operational community has on record this cycle. In early April 2026, a powerful westerly wind burst, a WWB, fired across the western equatorial Pacific. That wind burst injected substantial westerly momentum into the equatorial atmosphere and triggered the downwelling Kelvin wave that is currently propagating eastward across the Pacific. What makes this particular WWB notable is what it produced at the surface. The wind burst was so energetic that it spawned 3 simultaneous tropical cyclones across 3 different ocean basins. Cyclone Maila in the Australian region, Cyclone Vaianu in the South Pacific, and Typhoon Sinlaku in the Northwest Pacific. 3 cyclones, 3 basins, 1 wind burst. That is the strongest documented atmospheric signature of imminent El Niño onset on record this cycle. The named scientists who track this stuff for a living are not being subtle about what they think is coming. Jeff Berardelli, chief meteorologist at WFLA-TV in Tampa, has stated that the developing event, quote, could rival or even surpass the legendary 1877 El Niño, the strongest on record, end quote. Paul Roundy of the University at Albany has written about, quote, real potential for the strongest El Niño event in 140 years, end quote. Daniel Swain of UCLA has stated that, quote, the volume and the intensity of the subsurface warm water anomalies are about as large as we've seen in the historical record, end quote. The 1877 analog is the one you need to understand, because it changes the human stakes calculation entirely. The ERSSTV5 reconstruction places the 1877 Niño 3 anomaly peak at plus 2.88 degrees Celsius in the adjusted parameter ensemble. That is at or above the multi-model median forecast for the upcoming event. Historian Mike Davis, in his 2001 book Late Victorian Holocausts, documented the ENSO-driven famines of 1876 through 1878, 1896 through 1897, and 1899 through 1902. The combined death toll across those 3 events was between 30 and 60 million people. Most of the deaths occurred in India, northern China, northeastern Brazil, and parts of Africa. Singh and colleagues, in a 2018 paper in the Journal of Climate, attributed more than 50 million deaths from the 1876 through 1878 global famine alone to a triple whammy of anomalous tropical Pacific sea surface temperatures, an extreme positive Indian Ocean dipole, and warm North Atlantic sea surface temperatures. The combination of those three signals in 1876 and 1877 set up the regional drought and monsoon failures that produced the famine. If the upcoming event matches the 1877 magnitude, the pre-event drought you are watching in the United States right now is not a one-off. It is the leading edge of a multi-year atmospheric reorganization, and Florida is the first U.S. region to feel it. The immediate operational window on the Max Road Miramar Fire is the next 48 to 72 hours. Weather conditions in South Florida remain dry and hot. Wind shifts could push the flame front toward the Holly Lake defensive perimeter. The Florida Forest Service will issue updated containment percentages on a rolling basis. The most consequential question for this specific fire is whether the surface flames ignite the underlying peat. Once that happens, the fire is on the landscape until rain breaks the dry pattern. On the meteorological side, the next NUAA Climate Prediction Center ENSO diagnostic discussion is scheduled for this Thursday, May 14th. That update will revise the El Niño formation probability for the May through July window, the strong event probability, and the peak Niño 3.4 anomaly forecast. The June international climate updates from the European Center, the World Meteorological Organization, and the Japan Meteorological Agency will follow within 4 weeks. On the seasonal forecast side, a developing El Niño suppresses Atlantic hurricane activity. Colorado State University's April outlook called for 13 named storms, 6 hurricanes, and 2 major hurricanes, a below-average Atlantic season, primarily because of the ENSO transition. That forecast will be updated in late May. The Eastern Pacific Basin is the inverse. A strong El Niño amplifies Eastern Pacific tropical cyclone activity, which is the basin that produced this past April's triple cyclone signature. On the Florida-specific side, the wet season onset typically begins in mid-May for South Florida and late May to early June for Central Florida. The Climate Adaptation Center has noted that a generally weaker Bermuda high pattern is projected for 2026. A weaker Bermuda high delays sea breeze convergence rains and prolongs fire season risk. If the Bermuda high remains weak, if the El Niño teleconnection continues to suppress Florida precipitation, and if the southeast drought does not break by early June, the 4,800-acre fire that is leading the news today may not be the largest fire of this season. Let me give you the bottom line. 5 separate, since records began, benchmarks have been broken in a single season. The 131-year contiguous U.S. first quarter precipitation record. The 131-year contiguous U.S. March Palmer Drought Severity Index record. The 25-year Southeast Regional Drought Coverage record. The 25-year Southeast Drought Severity and Coverage Index record, and the 131-year state-level September through March records in Georgia, North Carolina, and South Carolina simultaneously. The Everglades fire is the visible surface expression. The drought is the body. The El Niño is the cause. The convergence is the story. The next 30 to 60 days will determine whether the 2026 and 2027 winter is a 2015 analog, a strong El Niño that the global system has dealt with before, or an 1877 analog. The difference between those two outcomes is roughly an order of magnitude in human stakes. We will be tracking this as it develops.